Let's look at this first example of an annuity. And we are now looking at future values. And you can probably guess what's going to be on later slides. We're going to be looking at annuity present values. So let's start with annuity future value example. You want to deposit $4,000 at the end of each year for the next 20 years in a bank account paying an 8% annual interest rate. How much will you have in 20 years in your bank account? Well, based on what we know, this is how we would set it up. So you would imagine this timeline. You show years in the future, years 1, 2, 3, all the way to 20. And under end of each year, you put $4,000, right? So you have $4,000 20 times in the future. And you place the question mark under year 20. So at the end of the 20th year, how much do you have total in your bank account? How would we calculate something like this on the earlier slides in this chapter? You would break it into pieces, right? That's what I taught you. You would first look at the first $4,000. What is its future value at the end of the 20th year, counting from today? Well, you would take 4,000, multiply by 1 plus the interest rate and raised to the power that indicates the number of years over which the interest will be earned. Notice that the power is 19, it's not 20, because 1 year is already elapsed. There are 19 years remaining between end of year 1 and end of year 20. And this is the correct power to be used for the first cash flow. And the interest rate was given at 8% per year. So I do 4,000 times 1.08 raised to the 19th power. Second $4,000. Again, we find its individual value at the end of the 20th year, counting from today. Between end of year 2 and end of year 20, there are 18 years. So this will be the power for this future value. 4,000 times 1.08 to the 18th. The next 4,000 will be, treated the same way. For its individual future value, the power will become 17, and so on. One before last, at the end of year 19, it only has 1 year to earn interest, and so we use no power at all. Or you can put power 1, it's the same thing. And the last deposit that you will make, $4,000 at the end of the 20th year, it's already where you want it to be. So it doesn't earn any interest. You deposit, immediately after that you check how much you have in your account, and from just this deposit you have $4,000, no interest on top. So you essentially broke it into 20 pieces, right? 20 individual future values, and then you add all of them up. Takes a while, possible to do, but it will probably take you, I don't know, a few minutes for sure. And just hope you don't make any mistakes somewhere. Turns out there is a compact formula for annuities, which looks like this. In our problem, you would take $4,000 for this repeating cash flow. You would multiply it by 1 divided by the interest rate, 0.08. Then what you get is multiplied by the next big term. In the big parentheses we have 1 plus 0.08 interest raised to the 20th power, and then you subtract 1. The answer would be $183,047.86. Notice how this is significantly more than simply taking $4,000 and multiplying by 20 times, which is $80,000. It's over $100,000 more than $80,000. Why is that? Interest. Interest, interest on interest, interest on interest and interest, and so on. So the extra $103,047.86 is pure interest, nothing else. Interest that you get from the bank. And you can also do it in the financial calculator. So if you go back to our problem, let's bring up the calculator. Let's clear everything. Second, plus minus, enter. We're going to learn a new button now. And the button is called PMT. Third row, second from the last. What do you think it stands for? That's right, payment. That's the dollar amount that's repeated again and again, the annuity payment amount. You put 4,000. We have many of those, and we want to find their future value, combined future value. So before you would say 4,000 as your PV, but we're not going to do it this way. We're not going to use PV button at all, because we have a whole bunch of PVs, right? 20 of those. Instead, we're going to call it payment. You press the PMT button. Before you press the PMT button, change 4,000 to a negative 4,000 by pressing plus minus key. And then press PMT. So now the calculator knows that you have $4,000 or whatever the units are, and that's going to be repeated a number of times. It's an annuity problem. How many times does it repeat? 20 times. You press 20 and then you press N. So here the interpretation of N is slightly different from the way it was used in the previous chapter to find the future value or the present value. Here N means how many repeating payments we have. Because technically $4,000 earns interest 19 times. So that's the right N we used for the first $4,000. The second $4,000 will be earning interest 18 times. So that would be the right N, the way we know what N is, from before. So we cannot put a whole bunch of N's, like 19, 18, 17, and so on. Instead, N, when we are working with the PMT button, N changes its meaning to how many repeating numbers we have. So we put 20N. Then the interest rate, 8 IY, as always. That's it. We don't need any more information. We have $4,000 repeating every year. The annual rate is 8%, and we have a total of 20 of those repeating cash flows. Then we press compute FV. And this is the number we got earlier, right? So this is exactly the same result, 183,047.86. That's in dollars. And the steps I just showed in the financial calculator are all repeated here. The PMT key is the new key we have just learned. And N now means how many cash flows we have. Interest rate just, stays as is. This is the general formula. It finds the future value of an annuity with T many cash flows evaluated at the end of the Tth period. So you take, the annuity payment, which is labeled as C, stands for cash flow, multiplied by fraction 1/R, then multiplied by open parenthesis 1 plus R, that term raised to the Tth power, then you subtract 1, close parenthesis. The way this formula is written is it kind of uses this multiplication factor, the cash flow that's repeating times something else. And this something else, this complicated term with fractions, powers, and parentheses, is known as the future value, interest factor on an annuity, or FVIFA for some interest rate R and number of cash flows T. And again, there is a table at the end of the textbook, Appendix 4, which gives you the value for this whole future value interest factor on an annuity for different combinations of interest rate R and number of cash flows T. But I'm not using it in class because, financial calculators are a lot more easier, faster, and more flexible. They allow for more cash flows than what that table shows, and it allows for a wider range of interest rates, like, partial interest rates, like let's say 5.1%. In the table, you would only see 5% or 6%, but nothing in between.